Sixth grade lesson 7.1 is teaching us about exponents. So let's go ahead and have a look at exponents. We are familiar with the fact that multiplication, like 3 times 4, is a shortcut for repeated addition, right? We know that that's 3 added to itself 4 times over. We've gone and memorized what those are to make it quick and easy, but that's what multiplication is. It's a shortcut for repeated addition. So what happens if we have a repeated multiplication? What does that look like? Do I want to be writing out 3 times 3 times 3 repeated, or can I write this in a shorter way? And that's what we're going to learn about today in exponents. So of course we know 3 plus 3 plus 3. I'm going to do this so that you can see the difference between the two. 3 plus 3 plus 3 plus 3. 3 plus 3 is 6. And then those added together is 12. That is not the same thing as this 3 times 3 times 3 times 3 repeated multiplication. You'll see these numbers grow very, very quickly. These get larger sort of quickly. These get larger very quickly because 3 times 3 is 9. 3 times 3 is 9. And 9 times 9 is 81. Very different answers. Repeated addition grows quickly. Repeated multiplication grows exponentially fast because it's exponents. So let's talk about these exponents. A couple of vocabulary pieces and how you say them is what I want to talk about first. Let me just show you an example. By the way, this example, 3 times itself 4 times over would be written as 3 times itself 4 times over, which is 3 to the 4th power. So let's look at the example they give in the book. They say, if I have 5 times 5 times 5, I'm repeatedly multiplying the same number by itself 3 times over. And the vocabulary for these words are the number that's being multiplied by itself over and over and over again is called the base number, base. The amount of times it's being multiplied by himself is the exponent. This little guy right there, he's called the exponent. That is how many times I will write this guy over and over and over again. I will write this guy 3 times over. 1, 2, 3, and then multiply them together. So this is the base. This is the exponent. The way you would pronounce all of these is 3 to the 4th power, 5 to the 3rd power, 7 to the 8th power, although that would be a gigantic number, by the way. It's always the base to the exponent power. There are 2 times where you might hear it pronounced differently, and that is anything to the 2nd power or anything to the 3rd power. Because sometimes you will hear people say things to the 2nd power as squared, mostly because if you have a square, right, and you multiply length times width, it's going to be the same amount. It's 4 times itself twice, squared. So you will hear people say 4 to the 2nd power, or maybe you will hear them say 4 squared. That means the same thing. It's 2 ways of saying the same thing. Both are correct. 4 to the 2nd power, 4 squared. 8 to the 2nd power, 8 squared. 12 to the 2nd power, 12 squared. Those are the same. The other alternate way of saying something is when you have the 3rd power. And the 2nd power and 3rd power are the only ones that do these. Otherwise, you just always say 4th power, 5th power, 6th power. The 3rd power, the alternate way of saying 3rd power is cubed. And when you think about it, if we took our square and then we turned it into a cube, to find the volume of that, we're finding 6, 6, and 6. They're all going to be the same because it's a cube, right? 6 times the length times the width times the height. That's 6 times itself 3 times over to make a cube. So people will use the term cubed for these sorts of anything to the 3rd power. So you could say 6 to the 3rd power and you would be right. Or you might hear it said as 6 cubed. So anything to the 3rd power you might hear as cubed as well. And they mean the same thing. So it's just trying to get into your brain that, okay, if I hear 4 squared or 5 squared or 10 squared, they really mean to the second power. If I hear 6 cubed or 8 cubed or 12 cubed, it really just means 6 to the third power or 8 to the third power or 12 to the third power. They're interchangeable. You can use either of those terms. After that, to the fourth power, to the fifth power, to the sixth power, there's no really interchangeable other ways of saying it. Most people just say the same, fourth power. So there's your terminology. Now let's get into looking at these. So the first part of this lesson is, how do I write this repeated multiplication in exponential form? And so remember, the base is the number that's being multiplied together. And here I have 3 being multiplied by itself. It has to be multiplied by the same number. So by himself several times over. So 3 is going to be my base number, the large number. The little number, the exponent, is how many times I'm multiplying this 3 by itself. 1, 2, 3, 4 times. And there it is in exponential form. They will get into the solving of these, how you solve them, but it's simply multiplication, really. 3 times 3 is 9, 3 times 3 is 9, and 9 times 9, 81. So this multiplication of it is fairly simple, other than taking time. Okay, here's another one. All they want us to do is write this in exponent form. So go ahead and try it real quick. Pause, try it, write it in exponent form, and then push play when you have it. All right, so now you must have it. Let's see how you did. The base is going to be 7 because 7 is what's being repeatedly multiplied. How many times is it being multiplied? 1, 2, 3, 4, 5 times. 7 to the 5th power is the answer to that. If you feel like figuring out how much that is just for fun, my fellow math nerds, go ahead and figure out how much that is by doing the multiplication. Pause it and then play. Okay, for those of you who wanted to know how much 7 to the 5th power is, it is a very large number. 7 times 7 is 49. 7 times 7 is 49. And then the 7 doesn't have a little friend there, so there we go. 49 times 49 is big. Okay, it's 2,401, I think. I did the calculations correct, I believe. Still times 7. So now I have to do all of that times 7. 16,807 is how much that is. They don't ask you in this section to do the solving of those numbers. And usually we have a calculator to do the exponents when they grow like that. But it's just kind of a good way for you to see. I went ahead and did that because I knew some of you are like me and like, I wonder how much that is. And it gives you a chance to see like how big, how quickly these numbers become gigantic. 7 to the 5th power, you would think is not that big, but 16,807 is how much 7 to the 5th power is. Common mistake we see in this is our brains are so trained on multiplication and our math facts that we see a 7, we see a 5, our brain says 35, right? And it's far from 35. So that's going to be the hardest part of exponents for you, is wanting to just multiply these two numbers together. Remember, multiplication is repeated addition, and exponents are repeated multiplication. So those numbers grow quickly. All right, so what if I'm faced with this, where I have all of this multiplication happening, but these two numbers are not the same as these two numbers? I mean, obviously we could just multiply them to find an answer, but that's not what they're asking for here. They are asking for us to write this in exponent form. Well, I cannot combine these. These are two different bases going on there. So I'm going to go ahead and deal with the two different bases that I'm faced with. I have this base and this base being multiplied together. This will be 6 multiplied together twice, also known as 6 to the 2nd power, or 6 squared, right? And this one will be 8 multiplied together 3 times, 8 to the 3rd power, or 8 cubed. And that's as far as my answer goes, unless they want me to break it down to how much that is. I can calculate it, but it's going to be big. I know some of you are going to want to do that, and I will do that in a moment. My answer for this, 6 squared times 8 cubed, or 6 to the second power times 8 to the third power is the answer to this that they are looking for in your book. Want it calculated? Go ahead, try it, and then push play. To calculate this, 6 times 6 we know is 36. Again, this is not something you're having to do for this lesson right now, so if you didn't calculate it, no worries. 8 times 8 here is 64. But I still have to multiply it by this other 8 over here. That's 32, 48, 49, 50, 51. And then I have to do the 36 times 512, provided I didn't make any mistakes in my quick calculation. 18,432 is what this equals if you were to calculate it. You didn't have to. We just did for fun. On this next example, they do want us to calculate it. However, they give us far easier numbers to do it with. So they want us to calculate out, find the value of 10 to the third power. And I've just always told my students, you know what, go ahead and write it out. Write out what it represents. This means 10 times itself 3 times over. 10 times itself 3 times over. And then go ahead and calculate it. Well, 10 times 10 is 100. Bring down the one you didn't do yet. 100 times 10 is 1,000. So 10 to the third is the same as 1,000. Another one they talk about here is 7 to the 1 power. That is 7 multiplied by himself on just the one time. So just 1 7 there. Done. The repeated factor is 7. The answer is 7. You're going to run into that on anything to the 1 power. There's 8 to the 1 power is 8 multiplied by himself. Just that one time, right? 10 to the 1 power is 10 multiplied by himself. Just the one time. 1,000 to the 1 power is 1,000 multiplied by himself. Just the one time. So anytime you see to the 1 power, you're just getting that, that base number being the answer. So that's kind of an easy one to deal with. Okay, and the final example they talk to us about is they want us to write the number 81 with an exponent using a base of 3. So we're using the base of 3, and we're going to keep doing it in exponent of 2, then 3, then 4, and so on until we hit an amount of value of 81. So they told us use a base of 3 in order to get the answer 81. So we start experimenting with it, and it seems like, man, if I'm counting by 3s, that's going to take me a long time. Remember, counting by is multiplication. We're doing a repeated multiplication. It becomes large very fast. So let's have a look at what happens here. We have 3 to the second power, or 3 squared. That is 3 times itself twice, 3 times 3, which is 9. 3 cubed, or 3 to the third power, is 3 times itself 3 times over, 1, 2, 3. And we know that 3 times 3 is 9. 9 times 3 is 27. This one is 3 to the fourth power, or 3 multiplied by himself 4 times over. Write it out. I just tell my students, write it all out, then do the multiplication. 3 times 3 is 9, 3 times 3 is 9, and 9 times 9 is 81. Well, there it is. We hit the 81 they wanted. How many exponents did it take to get there? The base of 3 is here. It took 4 exponents. So 3 to the fourth is what will get me to 81. So that's the lesson on exponents that they're showing you. They give you some practice ones. This becomes more, and it sinks in more and more with practice and over time. Work on this, see how you do. Feel free to use study buddies to help you with it. You'll do well, I think. Just remember to, anytime you need to, write it out. What does this mean written out? And then multiply it through if they're asking you to do that. Good luck.